Hi, welcome to tonight's vBrownBag. This is your host, Tom Green, and we have a great show tonight. Can everybody see my screen right now? Yeah.
Yes.
So tonight we're going to be wrapping up our AWS SysOps certification exam series talking about networking. And to talk about networking, we're joined by Anthony Chow.
Hi.
So we're hoping tonight's going to be interactive. I've just gotten word that we have no slides, so it's all live demo. We're going to start a little dance over here to the live demo gods that everything goes well. If you want to dance with us, you can get in on the conversation on Twitter. At vBrownBag is the main Twitter handle, and you can see the Twitter feeds for the other worldwide vBrownBag groups. If you use hashtag vBrownBag or at vBrownBag, you'll be in our queue. We'll interact with you, and your questions will be fielded by either me, Tom Green, at TBGRE00, or my lovely assistant, Chris Williams, at Mistwire.
Hello, everybody. A special hello to the new attendees out of the Atlanta region this evening. Talking to you, Pickens. Hi.
And without further ado, the reason you're all actually here is Anthony. Anthony, would you like to go ahead and start talking about yourself as I make you the presenter?
Okay, sure. Thank you. Good morning, good evening, or good afternoon, depending where you are listening. Thank you for joining vBrownBag. Well, today I'm considered very fortunate for myself. I have to answer to show my screen. I think everyone is seeing my screen with the cloud.
Yep.
Yes, we can see it.
So I'm very fortunate to be here tonight. To me, this is a big deal, and I consider able to present at vBrownBag as my career, one of my career achievements. So thank you for having me. My name is Anthony Chow. I'm a software developer for networking equipment in the past few years. But then I also venture into doing sysadmin, DevOps, blogging, and many other things in the technology arena. So I'm always want to try new things and see where I can fit in. I'm also a contract blogger for a cloud company where they give me a topic and I will write for them. But most of all, I have a passion to share what I have learned to others, and this is why I signed up to present. And also, there's one more thing is that while I prepare for the presentation, I think I learned the most. So this is one thing I push myself to learn more. So I encourage everybody. Even see, you can hear that I'm not an English, English is not my native language. But still, if I can do it, you can certainly do it. It's just a matter of sharing the information and talking in front of the computer. You don't even see the audiences. I don't know who is listening, and you cannot see me, so you cannot see my leg shaking, or you cannot see my hand shaking. So this is not that difficult. And then before the presentation, I also share with Tom and Chris that it feels like there are millions of butterflies flying in my stomach. So, but anyway, for sure, even though I present a few times, public speaking is still making me nervous just before. But hopefully, as I get into talking about AWS, I'll be able to settle down. Well, again, if you can see the previous slide, I am on Twitter. My handle is vClouder and Beer, and some of you might have heard about the story how I come up with this handle. And if you're interested, send me an email at vBrownBag. I mean, not vBrownBag, vClouderandBeer@gmail.com. I will tell you the story how I come up with my handle. Anyway, today we're looking at Objective 7 of the AWS SysOps certification associate level networking. And Jonathan told me I am on the 7th episode of the AWS SysOps series, and I'm presenting objective number 7. But usually when I take exams, the exam objective is my guideline. I would exactly know what I should be knowing. But if you look at the exam objective for SysOps, especially in the networking section, you will be disappointed because it's only 2-liner, and there's not much in detail about how much we should know about that. Usually, when I present about how to prepare for certification, the exam objective is my outline. But then today, since there's no outline, I have to come up with my own. And speaking of that, actually, just right before the presentation, I encountered an article at the SDN Central, because they said it's about Amazon networking. It's something about with container. So I also said, wonder when would this be included with the exam? I don't think it's in there yet, because it seems like there's something, especially for the area of netting. The net instance, there's lots of questions about net instance instead of the net gateway. So I wonder when this will be part of it. So, but for sure, we don't need to know about this in sitting for the exam. But so just, well, how do I come up with the exam? But before, you might be disappointed, even though I say today I have not any slides to show. That doesn't mean I am all the way in a live demo, because I believe in live demo, and I like to do live demos too. But just for preparing for the exam, doing some demo does not help much. And this is why I think my approach is go through how I prepare for the test and go through some of the important concepts. I think knowing the concept is important to sit for the exam. Sometimes we might not exactly know the answer, but if we know the underneath concept, then we'll be able to get a what do you call the educational or intelligence guess for the answer. And that I don't think wrong answer will deduct points. So this is so when I first start, I look at networking without a clear objective. I look at the networking products for AWS, and basically there are these four that I find: Amazon VPC, Data Direct Connect, Elastic Load Balancing, and Route 53. And tonight I'm not going to follow this exact order because of the importance. I think for sure we'll talk about VPC because this is the foundation of AWS networking. And then we're going to talk about Amazon Route 53, and then load balancing, and then lastly is the Direct Connect. Although I think this is before we get into network AWS. I think there's some fundamentals that we need to know. Especially this is a slide that I prepared. I kind of lie because I think I said there's no slide, but this slide is for another presentation I did for local VMelk group, that when they talk about this. But this is a basic concept, networking concept that we understand. Look, to sit for the AWS exam, we don't need to know all of these, but the important thing is that the OSI 7 layer model, I think, is important. And for layer 3 routing, I think is also an important concept to understand. Well, it's good to know about broadcast, multicast, and unicast, but for the purpose of sitting in the exam, it's not so important. This is the OSI 7 layer. And for AWS SysOps, we mostly deal with layers 4 and layer 3, the network layer and the transport layer. Usually, we will blend the terms TCP, IP together as one term. And in fact, if we look into it, this is actually a 2-layer. IP is one layer, and TCP, UDP is another layer. To uniquely identify a device, we need an IP address. But for the application that are running on that device, we'll use the port number. See, let's say, for example, for the web browser, HTTP, we use port 80. HTTPS, we use port 443. And this is how we differentiate. And sometimes for the VPC, we mostly concern about the IP address, and not so much with the port. The port comes into the picture where we configure the security group or the network ACL that will be that we need the port number, but mostly to identify a host or instance on AWS, an IP address is important. And later on, when we get into more about VPC, we know subnetting is an important concept that we need to understand. The reason that why I like this 7 layer is that the inner operation is that when an application wants to send something, it will just do, what's the right word to do, and they, all of a sudden I forgot the term, they add on to it. They add the headers from one layer to another layer, and then very down to the very physical layer to the other side. And then they will take out the layer, take out the headers for layer to layer by layer, and then they'll get to their information. And in between the routers, especially for Cisco router, Juniper routers, they use the IP address to do the routing to see where they need to forward. And also in AWS, we have the route table where we manually, or sometimes the system will do it for us, is that if the connection is depending on the route table to see where we can send the traffic. One thing I heard is that for networking, we always use the analogy of water pipe. The connection between host A and host B is just like we're establishing a pipe or flow, so we can send the data across. And this is how we should understand networking before we can get into AWS. So let's take a look at this. If you click this link, it will just go slow down to this thing. But what I found is this website is very comprehensive. This is how I tried when I study for the exam. This is how I get into the concepts and then start looking into the different aspect of it. For how if you want, I don't know what's the best way to share this link, but if you Google it, use the keyword AWS latest and then VPC, I think you will be able to find this. I think the VPC is very important concept to understand if we understand the networking aspect of AWS. Basically, I also took an online class about sitting in for the exam, and then for that class is that we should look at a VPC as a logical data center. I think this is a fair statement to say, because the things we are doing within VPC is just like we are configuring the networking aspect of a physical data center. And this is I think, I'm not going to read from this word by word, but I think before sitting in for the exam, I think it's good to go through the entire thing. And up here, there is a PDF file that has all the information of this, and then you can download it and read it at your own time. I think it's good. One thing I have heard is that if you can, without consulting any reference manual or website, and you can configure a VPC by hand, then you'll be ready for the exam. This is, at least this is the guideline for the VPC networking section. This is what I gather. And then, so we'll just go through some of this important information. So first of all is the subnet. I think we need to understand there is everything is based on the subnet on VPC. And VPC, we need to understand is that VPC spans across regions, and then each subnet is constrained to one availability zone. And I think this is important. Seems like there will be some question about if your subnet can be constrained to be one-to-one corresponding to a region or the availability zone. I think this is something we need to know. And for subnet, we'll go into subnet later on, but for this, at least for here, that there is the private subnet and the public subnet. So this, I think, this site we jump into, which is have a good picture. For me, I always said a picture worth 1,000 words, but as a software developer, I always say a picture is worth 1K 32 bits. Sorry about, I think 15 minutes into the presentation, I have to say some lame jokes just to keep everyone interested. Okay, we'll continue to look into this picture. I think I like this picture because mentally I can have a very good understanding of how things work. This is a more complicated picture, and then for this one, it has a lot of the elements, or later on, because there's one section called the VPC networking component. I think this picture, it represents a lot of the common things that we need to know. We understand the subnet, we have the routing table, we have the VPN connection, the virtual private gateway. We'll go into this later on, but this is one way to connect from your corporation, set up a VPN connection into the AWS cloud, or we can go through the internet. This is so if we mentally have this picture in mind, go into the exam, then we'll be able to answer some of the questions as a base. This is one thing so this is for the subnet part. Subnet is a very important subject, especially if you see there's the IP address is represented in the form, for this case, for example, is 10.0.0.0/16. This is the CEDAR format. I hope I say it correctly. I think CEDAR or CEDAR format. I think I find this article very nicely. This is, let's see, this one is very nice. It's an article on DigitalOcean explaining the IP address subnet and CEDAR notation for networking. I think this is very, I just want to go through it because I think it's important. Because usually what we'll find, for everyone sitting in the exam, this IP address is not foreign to us. But in reality, with the machine, even the router or the host machine on the IP stack, when they look at an IP address, they look at it this way. It's in the binary format. So this is 4-bit. That's why I say one word is 4-bit. So the IP address is fit nicely into a 4-bit, 32-bit word. So this is 192, 168. You can also say all 0 and then 5. This is the format. I think this is very important. And I don't think there is much IPv6 related questions, even not specific IPv6 specific questions, but this is another format. And also later on, if we go into Route 55 or DNS, there's an A record. A is for 32 bits, and for IPv6, the address is 128 bits, and that's why for IPv6, there is a AAAA4As record to represent 128 bits, because 1A of the address record is for 32 bits, so they have to expand on it. Anyway, this is not that important. For IP address, we have the different classes, the class A, class B, class C address, and you can read this for yourself. But I think sitting in for the exam, we need to understand about the net mask and subnets. Because for an IP address, it is for sure uniquely able to identify a device. But in fact, for the IP address, there are two parts. There is the host part and there's the network part. And for IP address or for the routers to determine how to forward the packets, maybe for AWS for the different subnet, what we call the subnet. How would we say it's a subnet? Because it's how we divide the IP address into the network and the host part. In this example, we have 192.168.0.15. Okay, when we look at this, yes, this can be used to identify one device. But when it tries to talk to some other devices, how does it work? With that, we have to understand the what they call the subnet mask. Usually, before we use the subnet mask, to see which portion, which is for 192.168.0.15, which this is easier. That's why for the binary number, which part is the network and which one is the host. And see, this is we can see from this is called a class C, and the default mask is 255.255.255, and this is the 255.255.255.0. This is the mask, and this is how we map the exact address, so we know this portion, the first three numbers are the network portion. But this is kind of not that easy. That's why they come up with the CEDAR notation, the slash. The 24 means the this number and the slash something, the number represent how many bits represent the network portion, and this is the subnet. Every device in the same subnet can just talk to each other. But if the device with an IP address of a different subnet needs a router to route, so we will look at subnet as a broadcast domain. And this is I think this will have a better understanding of how we come up with the site address. I think will help we understand some of these documents. So because for this a VPC for this in this example, the VPC is a /16, so the subnet is 10.0. Anytime if you have an IP address of 10.1, is on another subnet. Say for example, we have three subnet 1, subnet 2, subnet 3. They are /24. That means the first three is the network portion. So 10.0.2 is different from 10.0.1. If it is a /18, they will be on the same subnet. I hope this is clear. So before we move on, is there any questions or comments that we need to answer? So far, I don't see anything on the panel. Is there anything on Twitter?
There's just a lot of good comments. We've got one from Mike M. Mars on Twitter, who put out that link that you
oh, I see.
posted.
Thank you.
So he put that out for us. So thank you very much, Mike. And
Yes, thank you.
One quick question about the IP address reservations. If you're going to speak to that.
Yes, I will, because for this is the next thing that on this article is this. Is this what you're referring to?
The reservations that Amazon holds
yes.
holds in reserve. There you go.
The five ones. Yes, I'm getting there. Yes,
Okay.
Thank you. So after we know what is subnet, this is something to do with. This is a good rule that we need to understand. Is that because when we configure a VPC, we need to specify the address, and AWS allow us to be in between 16 to 28. And sometimes when you read an article, like for this one, first of all, I don't quite understand what they are referring to, because they are /16 or smaller. What does it mean by smaller? See, sometimes reading this technical article is that we might understand all the words, but what exactly does it mean? What it means by smaller? So I find out is that smaller means a smaller number of hosts that we can use. That means a bigger number. It's kind of confusing, but at least this is what he's trying to say. 16 or smaller. Smaller means less hosts, because if you specify okay, going back to the /16 and the /28, it says, in other words, VPC can obtain from 16 to 65K around IP addresses. If you have a /16, then you have 8 bits for your host. But if you have a /28, that means you only have 4 bits to be your host, so you can have 16 from 0 to 15. And this is a little bit tricky. Usually, it's not from 1 to 16, because when you talk about binary, this is you start from a 0. While I was in college, I got a B instead of an A just because of the 0 base and 1 base when I took the assembly class. But then anyway, this is not. We get back on track. I get distracted easily, so I need to constrain myself not to deviate my mind into something else and not related to AWS. So this is the reason I say this article is very good for preparation, because it's a lot of good information, and then it will be tested with this knowledge. So this is the range that if you have a /8, that means only the first one. So this is the reserved addresses. These are called the private. So if you configure usually for your private subnet, you will use these kind of ranges, and you depending on your need. One of the important thing maybe. So kind of the bad thing about not having a slide that the information I might be jumping around is that, and also so one of the questions that we asked in the exam may be, if you're running out of addresses, what can you do? one thing is that when we specify a subnet and with the size, it cannot be changed. If we need to increase the size, we need to create another. Let's say if you have a slash 28, you find 16 addresses is not enough for you. You need actually 20 addresses. Then what do? We cannot just change the size of the subnet and let it go. We have to create another VPC and migrate everything to the new VPC. And this is something, this will be one form or the other will be asked about how about this, because this is an important concept that we need to know about AWS, that the VPC subnet cannot be deleted. It has to be moved to a new one. And also we also mentioned there are some reserved IP addresses. The .0, .1, .2, .3, and the 255 are reserved. We cannot use this to identify a host when we try to reserve a IP address for the host. This has an explanation of what 1, 2, 3s are, and then 255 is always for broadcast. And the next item we see, look at this, is sizing for IPv6 is the same thing, and the subnet routing. And for this part, I think the most important is the routing table that we'll go into later on when we go with the VPC networking components, because route table is very important, because we need to know how to configure your route table. If the route table is not configured correctly, then we will not be able to have the connection between the two devices, especially if some of the times we want to direct the traffic with via the route table to the gateways or to another VPC when we do the VPC peering. So we go back to the net security. I don't think even though this is a VPC section, I'm not sure if we cover security group and ACL in the security objective, because I think this is, for me, I consider this as security, and I have not prepared anything. But anyway,
we covered that last week.
Yeah, so I don't need to go into it. But one thing is that what we remind is the security group is stateful, and then ACL is stateless. So we need to be careful of that. And there's no denying rules for security groups. But one thing I think for SysOps specific is that the VPC flow logs, we need to how to configure it. And there will be 1 or 2 questions about doing this, so we need to understand that. And then this is another way of configuring.
Hey, Anthony, sorry to interrupt.
Yes.
Quick. We did have a question about IPv6.
Yes.
And Mike asked if all of the AWS services were compatible with IPv6 at this point. Do you know, or can you comment on using IPv6 with AWS?
I don't know the exact answer, but I think I can comment on this, is that I think most of them are IPv6 comparable, but not all. And also what I have learned is that the extent is kind of old. So sometimes we might not have, well, IPv6 has been around for a long time, but then since it is not so popular within AWS, well, at least on my perspective, that not so many questions is IPv6 specific. I think if you know the answer for IPv4, it will be the same answer as IPv6. There's just a different form of addressing let's say going back to the subnet part, subnet portion, it will be usually be the same thing, just that instead of a 32-bit, we're looking at the well, take it back, IPv6, the format is a little bit different. It doesn't have the address, but it still has the CEDAR format. So I don't think there's too much question as IPv6 specific. Is there anyone that knows the answer that can help me out on this?
There are a lot of the services are IPv6 compatible. Not all of them, so you couldn't create. There's a couple that still are left over that are not IPv6 compatible. Most of them are, and they're getting more and more covered every day. I sent out a link for a comprehensive list of all the services that are covered by IPv6 in the chat channel.
Oh, thank you.
Yep.
Thank you very much.
And then the VPC peering is also an important aspect. I think we use the route to But one thing to remember about VPC peering is that they're non-transitive. So A talks to B talks to C. A does not automatically talk to C. We need to configure a route to do the VPC peering between A and C, because A can talk to B can talk to C does not mean A can talk to C. I think this week we should be able we should be covered. Well, this week should be covered by the previous episodes. So working on subnet, I think this is all good information. This is just the way how we create, how we don't need to go through, but at least I said getting the information from the online class that I took, it's good that we, at least before seeing in the class, especially with this SysOps, is that we'll be able to configure a VPC from scratch, maybe connected to the internet and try to ping from your console to your instance and to see if it works, and try to change some of the security group or ACLs to make it not able to ping and then get it back. I think if you can do that, then we should be able to pass the networking portion of it. So this is one thing we need to cover. The other thing is the networking. These are all good articles too. Oh, this is one thing about the difference between a default VPC and the VPC we created, because the behavior of the default VPC is different. And for the default VPC, all the subnets. See, this tells some of the characteristics. So one important differences between the default VPC and the VPC that we create is that all the subnets are able to connect it to assign both a private IPv4 address and a public IPv4 address. This is when we don't have any other VPC. If we connect our instance, associate our instance with a default VPC, this is the characteristic. Whereas if we configure our own VPC, this is not the default characteristics. And then there's also a routing table is created for you automatically. I think this is something we need to understand when we take the test. And then this one talks about the IP addressing. I think we went through before the differences between the IPv4 and IPv6. And this is a good information that we should. And also talks about the public IP address and the private IP address. And then this security, we get it covered. Especially the important thing is that we need to know VPC flow logs. And then for the components, there are something. The network interface, I don't think there is so much, but there's, well, you can see I already went to this page, so this must be important. So we need to understand the route table. And the major thing is that we will consider the target. And also for the destination is a subnet that we want to talk. So this actually, I thought to me that the word, maybe I'm not an English speaking, English is not my primary language. To me, the destination is not quite correct, because when you look at the route table, this field in fact is the subnet that you would be able to talk to this target. So I'm not sure if, but definitely for AWS, the documentation should not be that bad. It could be just me. So, but for me, this is, to me, it's just a reverse. It should not be the destination, because when I look at the word destination, it will be this destination IP address, because maybe I'm dealing with networking as a software developer. But this
it's a little bit misleading.
Good. Thank you. So this will be the subnet. Then we talk to the target. I think this is, we need to understand how to configure a routing table. And this is some, this has more information. This is very good, actually. In fact, how you migrate from one table to the other, they have different cases. It's good to understand, at least read this once before we go into the exam. And then again, the internet gateway is important things to know, because we have to configure an internet gateway. Well, of course, if it is the default VPC, the internet gateway is already configured. It's already there for you. And with this is only where we can connect to to the internet. But one thing we have to understand is that there's only one internet gateway is associated to a VPC. We cannot associate two internet gateways to a VPC. So adding, we cannot just add internet gateways. There can only be one. So if there is a question about how should I say, the bandwidth is not so well, can we, or there's a lack in the performance or response, can we add, what can we do to mitigate the problem? Then adding one more internet gateway is not a correct answer. So we cannot add an additional internet gateways to a VPC. There can only be one. I think this is something we need to know. Again, these are the good pictures. If you look at these pictures, you have a mental picture of how things work, and then it'll be easy to answer the questions. And then elastic IP address, I think we need to understand this also, is that the concept of an elastic IP address is that it is a persistent. This is assigned to you. I think it also charge you for money for using an elastic IP address, because this is kind of permanently assigned to you unless you delete it, or so this is something we need to understand. The term elastic IP address is for persistent IP address, and also this is for public. So this is pretty much another big topic is for netting. There are two ways. I think the new way is for netting instance, but then there's still a lot of questions about net. Sorry. The newer way that we are dealing with currently is net gateway, because it has we have a lot of good ways of convenience to being done for you, so we don't need to configure it that much. But I think there are quite a few questions about net instance instead of net gateway, and this is a good description comparing the two, and then going back to the net instance thing. I think one of the ways is that when we configure a net instance, it is important that we disable the source and destination check. This is one thing we need to understand, and also is that the net instance has to associate with a public IP address. And this is the same thing again. When you do the net, we need to update. This is to explain how you add an entry to point the subnet to the routing table to use the net instance. I think this is important. In the way the routing table is sometimes we just like manually assign a route. We configure a route to ourselves when we add an entry to a routing table. This is something good to understand. Again, this is a good map to good diagram to understand. So far, I think VPC peering. This is talk about VPC peering. This is good information. And then elastic IP address, it talks about it's a static. This is assigned to you instead of doing this. The address is permanent because some of the application, especially some of the application needs a persistent IP address, so we need to use this feature. So this is that is the VPN connections. This is also a good description on how we configure different things. This is a single VPN, and this is, let's say we have a different offices, one in Los Angeles, one in New York, and one in Asia. We can all configure this VPN excuse me, connection and point to the cloud. And then we can access in a more secure way. This is, I think, so far I have for VPC. So I don't see any questions on the chat.
Twitter's clear, it looks like. Looks like you're good to go.
So we move on to Route 53, which is also an important aspect. I think well, Route 53 is specifically stated in the except objective, although what about Route 53 is not mentioned. So I just want to go through some of these important things about, I think to me, at least to me, the important things about Route 53. Route 53 is the domain. I don't think I need to go over the .net, .com, .io domain names. I think this should be for this audience. This should be okay. We don't have to go through that. And I think it's important to go through the more about the features or what we can do with Route 53. This is, I think, the one of the things is that we need to know provide a health check for your resource for Route 53, and then at least one of the things is the routing policy for Route 53 that will go later on. But then for Route 53, I think there are a few concepts that we understand. We talk about the A record. A record is the translation that we map the name to the IP address. We use the A record, and there's also the C name. The canonical name is that we map the what's that called, the one domain name to another. This is how we use the C name, and yes, the canonical name. And then there's also alias. Alias is, I think, is a feature within AWS that's similar to CNAME, and alias is something sometimes we can use it for elastic load balancing. Maybe I don't know if we have time to go into later on for elastic balancing. I just want to mention it here is that for elastic balancer, we don't assign our AWS. We do not for the use as a user. We don't see the IP address for it, although eventually it will be resolved to an IP address. But for the elastic load balancer, we use there's also use a name to identify. So an alias is also being used to address this. Then another thing I think I get it from the online class that I took is that if we have to choose between alias and CNAME, always use the alias, because alias is free, and then for CNAME, I think the fee incur for that. This one is another one as well. I think this is something we need to understand is the different routing policy. These are the different routing policies that we have, and this page has a good description of what they are. And briefly, we'll just go over is that for simple routing policies, this is a very good. I would have to say, AWS is the best documentation provider about their product. It has very good documentation. Even though they use simple words and directly maps them easily. For simple routing is when you have a single resource that perform a given function. And then for weighted is that you have a multiple resource perform the same function. But then you want to, let's say, sometimes you want, even though they use the same function, maybe for the blue-green test, that you want to put something new into production, but I just want to test something out, then you can use this weighted routing policy to put maybe 20% of the traffic to the new application, the new version of the same application, and then the rest is that so that you can test things out. So even though there's some kind of a bug, that the whole thing will not blow up, and you still be able to maintain up some kind of uptime. And then for latency is that depending on the latency, it will route it to the different resources. This again perform the same function, and you want it to respond to a query with the resource that provides the best latency. So I think this is a good feature that if we have the website, this is a good routing policy. And then the failover again is an active passive. If you do the health check, then it will do the failover, and then fail over to when AWS detected your application is not healthy, so quote unquote not healthy, not responding to the query or ping, then they will fail over to the other one. And then geolocation is that this one, if you have a worldwide, if you are, let's say, if you're in Asia, you're in Japan, then you do not want to access an application that is hosted on the well, West Coast is still okay. You don't want to host an application that's on the East region. So the geological routing policy will respond to you the appropriate based on your geolocation. I think there should be some question about this routing policy, even though it's not in the exam. I think this is important to know as a system operator to know about these different kinds of routing policies. I think this is pretty much about the routing policy. Again, questions? No, I don't see in the chat before we move on to load balancer.
No, I had a question, but I think you're going to cover it right here with load balancing. So if you haven't, I'll hit you up at the end of this section.
Yeah, then we will move on to load balancer. Is load balancer again? This is before there's also the classic elastic load balancer, but there's also come up with the application load balancer, which is supposed to be much better. And I heard, especially if you see this one of the features that it supports HTTP2 support. HTTP2 is a much faster protocol because I think it supports bidirectional. And there's a website you can go. There are two pictures continuously refreshing each other, a same picture. But then one is using HTTP1 and the other one is using HTTP2. You can see the one that is using under HTTP2 is very stable, and yet the one that's using the standard HTTP1 is refreshing quite in a slower rate. You can see the differences. But then I'm not sure there's much about application load balancer in the exam, so we don't need to have to put too many emphasis on looking into this, but we still need to understand what the classic load balancer, and these are the things. Like I said, there is no IP address associated with the load balancer. It's always username, and then we need to have I have another thing is that there's a good article from Sumo Logic that has a comparison about the two. So you can take a look and then see if the newer application load balancer is a good way for you to go. But for the purpose of certification, taking the exam, I think we still to read into the classic elastic load balancer. Tom, what the question you have? I don't think I covered the question you're going to ask.
So I was going to ask if you would expect any questions saying when would you use an elastic load balancer versus Route 53 load balancing, or if you could talk kind of when you would use one versus another.
I think they operate in a different level, but there's lots of better built-in features in the application load balancer. And I talked to some of the AWS evangelists. They push, well, when I talk to the evangelists, it's in the context of a container. But for the container, especially for the service discovery, they said there's a lot better for container to use application level balance than the elastic load balancing. I think maybe this article we have a better explanation of which one to use, which other, because they compare. I think this will be able to answer your question because of the ALB use cases. It talks about more about these things.
Great, thank you.
Should I post the link on the chat?
I'll put it out and get it on Twitter for you.
Thank you. It's a Sumo Logic page. And this is for load balancing. I think this is pretty much it. Then the last one is Direct Connect. So this Direct Connect is that one of the benefits of Direct Connect is that we'll be able to save bandwidths. This is not going through the internet. These are specific connections from your site into AWS. So this is something, this is how we configure this. I think the questions that we want to know, well, to answer the question about this direct connect related topic is that it is able to, the two keywords I think we need to understand is HA, high availability, and bandwidth requirement. It's safer to use because we're not going through the internet, and then it's to be able to provide a better HA and then the safe bandwidth if we use this. And this is something, I think this is what we need to know about the Direct Connect when we go sit in for the exam. And I think this is all I have for the networking section.
Well, great, thank you, Anthony. Could you kind of give some tips or resources, maybe the AWS website too, that you used to prepare when you took the test?
The website for AWS, the one I went through is the one I went through. I read the whole thing. I download the PDF and then read it line by line. Also, some of the online classes are pretty good, and I'm not sure I should say it in here, is that one of the online class I think is very popular, and then everyone said it's very good. And I have the same experience. I think this is they have good exam tips. So I'm not sure if I should say which.
Yep, go ahead and plug
it. It's A Cloud Guru. I think everyone has a high opinion on that. Not only do they have good information, the content is good. They also give good exam tips.
Yeah, I've watched some of those videos. I think they're pretty great myself.
And well, good luck on taking the exam, whoever is taking it, and I hope this vBrownBag series is helpful.
All right, great job. Thanks everybody for attending, and I'm going to go ahead and stop the recording now.